With that, I'm pleased to welcome today's speakers. We have Sarah Hager, who is a research associate in the Water Resources Center at the University of Minnesota and an adjunct assistant professor in the U.S. Department of Bioproducts and Biosystems Engineering. And Neil Ryder, administrative engineer in the Water Services Unit, and my coworker now at MnDOT. That'll turn it over to Sarah, who'll present first.
All right, does that look good on your end?
That looks great.
Looks good. All right, thanks everybody. Well, I'm happy to be here today to talk about the research and the partnership we've had with MnDOT. And if there's anything I want to start this presentation with is how much of a partnership it's been. So we're going on 12 or 13 years that we've been partnering with MnDOT. And I think what you'll learn from today, it's been really beneficial for both our programs, the work we've been doing. But with that, I'll get into the topic at hand. I do want to just provide just a little bit of background about our program at the U of M. So you can see since around the mid-1970s, our program is when it began. And that was really due to the greening of our lakes. Again, I wasn't here in the mid-70s, but the two gentlemen who started our program really were brought in because we were seeing increase of algal blooms in some of our lakes across Minnesota. And one of the likely suspects was improper wastewater treatment, particularly from septic systems. So that really led to a training and certification program that has really grown since the 70s. It started as a voluntary program, and now it's a mandatory program, which is regulated by the MPCA. But our program does all of the training. Well, I would say a majority of the training that's needed to become licensed and then to keep up continuing education. So you can see since the mid-90s, that program has been doing that education. So it really has helped sustain our program. So our program is actually 100% soft funded based on workshop revenue and fees, and then research. So and our program has always been trying to answer questions that people face in the field. So we do very applied based research. Because in the end, what septic systems really are, and we're going to talk about decentralized wastewater treatment a lot today, is they're really a blend of an understanding of soil science and engineering. So we have expertise within our program from both sides of that. So Dan Wheeler's name, who was on my first slide, is the soil scientist in our program, and I have an engineering background. So and so this project, again, with MnDOT has allowed us to do a wide range of research activities, which I'm going to hit the highlights of today. So my agenda for the 30 minutes I have with you is to do an overview of really the issues. And again, I'm not going to get all the safety and really, all of this work started from an evaluation and risk assessment of the wastewater treatment issues at the rest areas and truck stations. And then at the end, I'll hit on just some ongoing research activities. So first, talking about those safety rest areas. Until we started this project, everyone had been to a rest area. Hadn't thought much about them, but the one thing I just want to highlight that I have come to appreciate is how amazingly clean they are. So that again, you don't have to buy anything, and sometimes when you go into a gas station, you never know what you're going to get. But when you stop at a MnDOT rest area, you're always going to get a nice clean bathroom. So there are 52 safety rest areas, and really they were put in place, right? So people wouldn't drive long stretches of the road. They had somewhere to stop. And now there's fancy ones, right, that have somewhere you can exercise your dog. And I think we do have a wide range of rest areas, some that have more modern amenities, some of them that are a little bit more rustic, but again, all have clean bathrooms. And if you think about the last time you stopped at a rest area, most of them, again, are along a highway, a freeway, a major road, and they're not close to a town. So they were meant to be kind of something that would break up your drive. So they are traditionally not connected to municipal sewer and water. Some of the truck stations, that's not the case, but certainly the rest areas that is. But there are many rural truck stations as well that aren't located within a municipality. When you think about also when septic systems and when rest areas really, were first developed, many of them are getting older. And so not thinking about, from my perspective, the building being older, but certainly all of the infrastructure is getting older, including the septic system. So really, I think when we started our partnership with MnDOT, with Neil Ryder, who's going to be talking later, he had recently kind of inherited all of the infrastructure, including many of these old septic systems that were likely in need of replacement. But, when you think about having a lot of things that might need replacement, how do you actually prioritize that? So that really was the goal of how this project started, was to evaluate every single system, to not make, assumptions, but to look and go out in the field and look at each system. And then working with MnDOT to develop a risk framework. So how they could think about planning for the future, again, over the next 5, 10, 15, 20 years. And, I think the other nice thing is that once you have a good inventory, it also gets easier to think about planning for the future and when upgrades might be needed long-term. So the framework that was developed was meant to support and be a decision support tool. Certainly that then assists with budget planning. And again, I think the great thing to us that I don't think we knew at the U of M when we started this project is we would have sites where we could continue to do research. The great thing about these rest areas is they are used all year round. There's some seasonality to some of them based on where they're located. But in general, they're used by a wide range of people at a pretty consistent level, and they're very accessible. So they're really good locations to do and test research activities. I will discuss, though, they're not exactly the same as what you would envision at a house or maybe even at a resort, because they're a little unique in what happens when we go to the rest area. So overall, I just want to take one step back, and that is septic systems are very important in Minnesota. As you'll see, there's over 600,000 septic systems in Minnesota, generating, and that's on an annual basis, 43 billion gallons of wastewater. So it is really important that septic systems properly treat the contaminants that we put down the drain and recycle that water back into the environment. You'll see 3/4 of people in Minnesota are drinking water from the ground. And so when you have a septic system, the water's going one of two places. It's either going into deeper groundwater or it's moving laterally to a lake, river, or stream. So again, that's why septic systems overall are really important when you think about protecting all of our water, whether it be groundwater or surface water. So the picture on the right again shows a system in a backyard, which we'll talk a little bit more about. But every septic system starts with primary treatment, which occurs in the septic tank. And after that, most septic systems again go out to some sort of soil treatment system. This system shows an in-ground system, which is a drain field. Many sites also need to have mound systems that are elevated due to high water table or bedrock conditions. It's also very common, like you see here in the picture, that most Minnesotans have their own private well. And that is also true of MnDOT rest areas, is that we don't have public water. We are pulling up our own groundwater. So I also just want to highlight how our septic systems on the broader scale fit into this. So again, whether you're in a rural landscape like you see here, or again, think about that being a rest area, is that we are often either recharging groundwater or recharging a lake, river, or stream with the effluent from our septic systems. This is also true again of some municipalities that are pulling up groundwater and sometimes discharging into lakes, rivers, and streams. But again, septic systems are always discharging subsurfacely. That is the big difference between traditional wastewater treatment plants and a decentralized septic system. So as I mentioned, most septic systems start with really a simple primary clarifier, which is really what a septic tank is. The wastewater does spend several days in that tank, so we do also get some anaerobic digestion. Then with most systems, again, our final treatment and disinfection happens in that subsurface soil treatment system. And we rely upon 3 feet of unsaturated soil to remove the organics, to remove particularly the bacteria and viruses, the phosphorus. There are additional pre-treatment steps that can happen before the soil. And, there are certainly MnDOT sites that employ advanced treatment in between the tank and the soil. Those are more commonly used when you have either a challenging site or soil condition, or with some larger septic systems. So larger might be clusters of homes, or might be something like a rest area. So I do want to highlight, though, that MnDOT facilities are different, and that was some of the things we evaluated during our risk assessment. The first issue you'll see is flows. The flows are going to be higher than typical homes. And again, there is some seasonality, particularly with some rest areas. I think about, for instance, the one outside of Brainerd on 371. You can envision that, yep, some people go up in winter, but boy, do a lot of people hit that facility in the summer. But then you might take another one, Albert Lee along 35W, might be busy all year round, but there are some seasonality issues. The second issue is strength. The waste is much more concentrated because when you go to the rest area, what do? Right? You flush the toilet, and if we're lucky, hopefully you wash your hands, but there's no showering, there's no laundry. So the third thing is, and this kind of relates to the strength, is there is a lot of cleaning. I mentioned how nice and clean MnDOT facility rest areas are, but there is a consistent use of products, and at, I would say, a slightly higher level than most homes, maybe not all homes. Our fourth challenge is where these systems are located. Often rest areas are built again on a side of a road. Maybe there was previous construction debris or staging that occurred, or why did we end up with this land? Sometimes it's because it wasn't desirable for other reasons. So that can create challenging site conditions. And the last one is the systems. The systems in general tend to be not as simple as what we see in typical backyard home septic systems. So when we first went out there, we ran into things like siphons. I had actually never seen a septic system that employed a siphon, and that's not super complex technology, but it just highlights how we tend to see more pumps, more lift stations, more things that need to be taken care of. So here again kind of highlights the big project we had, which was in 2014 and 2016, where we went out and evaluated all of those septic systems. So it started with really developing the protocol, like what are we going to go out, what are we going to look at? And, we went to a few sites to test it, because until you really get out in the field and start looking at systems, you may find things that you missed. So after that, we then performed the actual assessment. So that was, again, visiting all of them and gathering all the information, which I'll highlight what we gathered coming up. Then we developed recommendations, and all along, this work was all done hand in hand with MnDOT. And then finally, we completed the risk assessment. And after I'm done, Neil's going to talk more about how they really took that risk assessment and moved forward with it. So some of the data we gathered, we started with inside the facility, looking at, again, how many toilets, how many gallons per flush of the toilet, how are the sinks set up? Are they manual or automatic? What other water usage? So do they have any water conditioning or water treatment? What are the cleaners and chemicals used within the facility for sanitizing? So we then gathered additional data that was inside, would have been the flows. So all of these MnDOT rest areas in particular had been writing down daily flow meter data, which I'll just tell you most facilities don't do. So we had some pretty good daily flow data. MnDOT has gone to automating more of that data, which is great, but it was great that at this time, think about this many years ago, they had been gathering that daily data. Because then we're not on city water, so we didn't have that other infrastructure built in. The next one is we measured the organic content. So the BOD and the COD and the TSS were all just a measure of, again, how concentrated is that waste stream. And then the last one is the nutrients, the nitrogen and the phosphorus. Anytime you have primarily toilet flushing, these are going to be elevated compared to typical domestic strength waste. So then after we kind of gathered that data, we then really looked at the septic system itself. So everything from how often had they been maintaining the system. So those septic tanks do need to be cleaned on a regular basis. Are there any problems or challenges that had been faced? But then really the nuts and bolts of what was in the ground. So most of these systems had drawings, but the drawings were what was originally engineered. So comparing that to what was installed and what was the state or the condition of each of the components. So the septic tanks, how the wastewater got from the septic tanks to the dispersal system. Was it gravity? Was it siphoned? Was it pumped? How large was that soil treatment system? And did that match the flow data? So when these facilities were designed, they had to estimate what the flow data would be. And again, then the status. So how well was each component performing? And then even something simple as what's growing over the top is a very important issue. You don't want trees and brush, right, growing over the top of a soil treatment system. So this data was then all fed into a risk assessment. The risk assessment had both a rating and a weight to many of the variables. We really gathered, I think at the end of the day, over 30 different things that could have fed into this risk assessment. And we really then had to determine which of these really was impacting the risk to public health and the environment. That is what septic systems are designed to do, is protect public health and the environment. So the weighting was either given a low, medium, or high. And it was a case-based reasoning approach that was taken to our risk assessment. So this risk rating, and again, Neil will talk a little bit more about this later, was based on an existing MnDOT rating scale that was used for other infrastructure measurements as far as, what status are they? So that scale, again, being 1 to 5. So we ended up using 18 properties that both best differentiated and indicate risk, though that's what we selected. And we had to use some expert knowledge to rate each of these properties. So here's just one example, and I can't get into great depth, but one that I think is kind of easy to understand is flow. So as the system goes up in scale, the risk that it poses to the environment is greater. So I haven't talked as much about the truck station. Those are, again, pretty small flow systems, generally just serving the employees that work at that truck station. So those were all in the low flow category. So for this, they would have, again, had a low risk factor. But again, as the flow went up, you can see, so there were 8 in that smaller category, and then only 2 that really were above, that had that, and I have trouble with this high, but high risk factor being 1 of being over 5,000 gallons per day. So, and that in Minnesota, again, most of our systems, again, generally fit into those low flows, but we do increasingly have more and more community and cluster systems being built. And that's a lot more water that is going out into the environment. So then our examples of that case-based rating that we added. So looking at this and just some example of how that was used. So their average flow also either for each of these we would either amplify or keep it as is. So that average flow, you'll see here 1.5. If it was surfacing, that was viewed to be a bigger issue. So certainly if the area was spongy as we walked over it, or there are signs that the system had surfaced, that got amplified in our risk assessment. If the aquifer the system was sitting over, again, was sensitive, that got slightly amplified. Or if it didn't meet its separation to the limiting condition, that also would have been amplified. So where we ended up, we had in the high risk category, again, there were 7 systems that really fit into that. We did not have any that were 1, which would have been very, very high risk, but we had 7 in that category. We then had, you see, of the 3s and 4s, if you add again those together, we had an additional systems there, and then we had 5 that really were very low risk. So this then again, these results could then be taken and used by MnDOT to obviously prioritize which systems are we going to evaluate, are we going to look to improve in the future. So that's kind of an overview, and with that, I'm going to go into some of the follow-up research. The nice thing about this research is it's also been a way to involve students and grad students and other professionals learning more about septic systems. In this picture, you'll see several students who've gone through our program, one recently completing a master's. I'm going to discuss a little bit of her work today. So after the first project was done, again, we thought and met with MnDOT to talk about, well, in what areas do we need more information? So the first one, and anyone I have a star by, I put there so I remember I'm going to talk about a little bit more in detail, but water table monitoring, if you remember, one of the risk categories I showed is that it didn't meet its separation. Well, again, how we generally determine if a system meets its separation is by looking at the soils and redoxomorphic features. But you can actually monitor where the water table is. So that has been a really useful ongoing project to help more, I would say, get more detailed information about how often is the system truly not meeting its separation. The second one was, again, some educational work that was done, which I'll discuss. We also started sampling flammable waste traps. And this was really the phase 1, which we'll get into more here, was really looking at, again, what's in those flammable waste traps, what's flowing through, particularly when we're washing down trucks. And what are some of the options to deal with some of that waste, which is very different than the waste we've talked about so far. The next activity during this project was development of O&M manuals. So again, if you think about those 52 septic systems, they didn't have O&M manuals. So this was, and the people often managing those on a day-to-day basis are not septic system professionals. They wear many hats. So giving them a tool that they could utilize to understand what do they have and what do they need to take care of it. The next thing we did was a water use study, which I'll highlight coming up, and a couple other fun things. We tried to figure out if there's a better toilet paper, and we didn't come to any strong conclusions there, but and then the last one is we looked at potential impacts from some of that water softener brine water. So here's just an example of water table monitoring, and this graph is probably a little hard to understand, and I don't think the details of this really matter, but what we have been looking at is, again, and this is again a specific rest area, Rum River, if you happen to know where that one is, which was really, again, built, and MnDOT had very few options about where to put the septic system. So the goal here was, again, they built a system that had its own 3 feet of separation. And then, so what we've been doing over time, and again, that's where that 3-foot line is at the top, has been really monitoring where the water table is within the system to confirm that we're, again, meeting our treatment goals, along with also monitoring precipitation, which are the other lines that you see. So this, again, this area, this is actually a relatively new septic system that was recently redone. But if you think about also with some older systems, this could really help prioritize upgrades. So here's a picture of one of the educational signs. Neil's going to show a couple other of these as well. One of the biggest challenges, again, with users of some of rest areas is what they sometimes put down the drain. So this one is more something that you could see reading outside to think about, so people think more about what septic systems are. Some of the more interior ones were done to do more education about what should and shouldn't be flushed. So the water use study really dated back to when these septic systems, many of them were originally designed. So you'll see in 1979, MnDOT actually did a water use study. You'll see they found if the site had water conserving devices, it used 2.8 gallons, non-water conserving devices 4.5. It was expected that these numbers probably had shifted downward, but we didn't have any data. So we actually put in, I think our study may have probably been a little bit more precise than when was done in 79. We actually put door counters in, so we knew when people were going in or out, which is more accurate, although they probably had someone standing there for shorter periods of time counting. So the results you'll see, we did do some comparison between interstate and non-interstate to see if there was a difference, and you can see a bit of a difference. No really good answer necessarily. The theory could be less cleaning or water treatment may impact that, as some of the interstate rest areas tend to be a little busier. So the next one I wanted to touch on is reuse at truck stations. So this, again, the goal is there a way to think about that water, particularly that was being washed down from trucks? We did a big overarching look at reuse. We are, to me, we're reusing all of our wastewater. It's just a matter of how soon. So what we were looking at here, is there a more direct way to reuse wastewater either within a facility? So that was the big picture. So we did look at, where does it make sense from a regulatory and environmental and an economic impact, and then provide some recommendations about where reuse might make the most sense. So this also led to some sampling of that washdown water. So one of the highlighted waste streams was that during winter, when trucks come back from having put salt on our roads, they need to be washed down. You can't leave that salt sit in them, or it'll impact them. And typically that brine is either one, going to a holding tank, or two, directly going to a municipality. And if it's going to a holding tank, it's often pumped and taken to a municipality. Well, many of us have heard that chlorides are a growing challenge in many of our surface waters. So it was a logical point to say, well, can we take this salty water from our trucks, and could we use it to make brine? So we went out and sampled that water, and we found that there were some organics that just tend to come with the water. And there was a bunch of chloride, but if you're looking to make brine with it, the chloride's not a problem. If you were looking to use it on the landscape, obviously it would be. So after this research was conducted, it was probably one of my happier moments in doing research, is that the research was taken and implemented. So we made some recommendations about some options that could be done to deal with the organics. And MnDOT went ahead and installed 2 pilot reuse facilities that now are taking that truck washdown water and they're creating brine. And I think we can expect, I hope, to see more of this in the future. So the rest of these I'll go through a little quicker, so I meet my 30 minutes here. So we've continued the water table monitoring. We continued the flammable waste traps. We moved into phase 2, which was the demonstration. We also started looking at some additional things, and that is evaluating the soil around septic systems and really looking into how do septic systems deal with contaminants of emerging concern. So this is something, again, I expect most of you have heard of, but there are the chemicals of emerging concern that we were really focusing on are the ones in the middle, right? So that are based on human consumption. Personal care products, certainly pharmaceuticals. If you think about people using the toilet at rest areas, that's what we're going to get. And so we're really looking into the treatment mechanisms that are occurring in septic systems. So physical, biological, and chemical treatment that could be occurring within septic systems. So we've been, again, thinking about the source, which again would be coming out of the rest area, sampling what's leaving the septic tank. If systems have advanced treatment, we've been sampling there. We've then also been sampling the soil and groundwater to kind of follow how do the CECs break down throughout the septic system? And again, I don't have a lot of time to get into details. If you're interested, you can feel free to reach out. But you know, here's just results of one field study where of all the CECs we were looking at, 6 we didn't find at all. 15 were found in the effluent we were measuring septage, but now not groundwater. And then we had, again, some different sites, and sorry, site 3 should have been moved down one, but you'll see 14, 12, 1, 0. What does that tell me? Well, it wasn't consistent. So we found some of this, again, sticking in the soil, absorbing to the soil at some sites and not other sites. The other consistent trend is there are a lot more CECs in the septic tank than groundwater. So we do know that the septic systems are in fact removing contaminants of emerging concern. So lastly, what are we working on now? Well, we're still monitoring water tables. We actually started doing some temperature monitoring to see what kind of temperatures we have in the soil and how that could be impacting treatment. We're looking at the waste that actually comes out of flammable waste traps, which would be more sand and debris. We did a laboratory, a more controlled greenhouse study looking at CECs. We're going to be moving into looking at groundwater mounding, continuing to do soil properties. And kind of the last thing is looking at, well, what about when these tanks get cleaned? And that waste is referred to as septage. So looking at what is really the concentration of that waste and what are the options. And the last thing is our septic tank designs have changed very little since they really came out in the 50s and 60s. So we're looking at some modifications that could potentially improve that primary treatment that occurs in septic tanks. The septic objectives, the only other thing I'll highlight here, I kind of covered this well, is we're also doing a little bit of look at PFAS levels that because that's certainly an emerging contaminant. And we don't expect rest areas to be a large source of PFAS, but we probably all heard it's even in toilet paper, so who knows? So for more information about the research we've done, our website across the bottom there, septic.umn.edu/MnDOT, has all of our MnDOT studies. Our CEC research is currently going through the publication process, so we don't have anything posted right now until it goes through the peer review process. We can't release it, otherwise they won't publish it for us. So with that, my name, email address, our website again, and I look forward to any questions you have at the end of Neil's presentation.
Thank you so much. And I just want to remind folks to start typing your questions in the Q&A chat box. So I don't see any questions yet. Can probably move to Neil's presentation. Thank you so much. That was amazing. Thank you. And I do have some questions, but let's save it for the end.
Yeah, thank you, Sarah, and thank you for covering all of that. You can see my screen, right?
Yep, we can see it.
All right, thank you. And so, yeah, I just wanted to, so my name is Neil Ryder, and I'm the Water Services Engineer for Minnesota Department of Transportation. I actually work in the Office of Maintenance and the Building Services section. That's a central office function. I know I'm showing here a picture of actually a wastewater pond. That's some of the other wastewater infrastructure we own and kind of operate. And the only reason I'm showing a wastewater pond at a septic presentation is mainly because septic systems are surprisingly not photogenic. And so it's basically looking at grassy fields. So this was at least a little bit of a pretty picture of something we own. So that's kind of why I included this here, just to highlight that we own a number of different types of facilities. So just to preview what I'm going to talk about here today, I'll briefly go with some fun facts about MnDOT and kind of our wastewater systems here too. I'm going to touch on the research study that Sarah mainly talked about. I'm going to kind of give more MnDOT's perspective and why we did this and why we wanted to conduct this. And basically, a lot of it actually had to do with kind of O&M and improving our systems performance and our knowledge of our systems, how like we've continued to use that research and how it actually relates to our current work and what we continue to do. And, you know, and really like, so I'm in the office of maintenance, and the end goal of almost everything that we do is always trying to make our systems as robust as possible while making them as easy to operate for the district personnel that kind of operate and maintain these systems on a daily basis. So we have a almost like a laser focus on maintainability on these systems that we need them to operate. We're not trying to turn MnDOT personnel into wastewater professionals, but they need to know how to operate it, and we need it to be as easy as possible. In this picture here, that's an example of what a septic system looks like. It's essentially just a grassy field. And so that's kind of why my first picture was of a pond, just a little bit more attractive. So fun facts about MnDOT. So MnDOT owns and operates, we have over 900 buildings with over 6.7 million square feet. That includes truck stations, regional headquarters, maintenance sites, special service sites like our Monroe facilities, our training center with 173 salt and sand delivery sites, and then 68 combination rest areas, or I shouldn't say they're not combination, but rest areas and traveler information centers. And the image on the right, really, that's just that's showing you where all of our facilities are located. The blue symbols and the question mark symbols, those are our rest areas, and the question marks are actually traveler information centers. So those are tourism sites, or they have a tourism component to them. If you map the blues with your eyes, you can kind of see I-90 along the bottom of the state, kind of 35 going up to the North Shore, and then Highway 61 along the North Shore, and I-94 kind of cutting across the kind of from the metro up to the northwest. And so those are all of our rest area facilities. The yellow dots, those are all of our maintenance, truck station facilities and headquarters. And then the gray kind of plus symbols, those are just some of the miscellaneous sites that we have. So, you know, our facilities, as that image just showed, they're in all corners of the state. And they're not always located, as Sarah highlighted earlier too, where utilities are present. So no water, sewer. And the end result of that is we own 54 SSTS systems. That number has changed a little bit from when we started the septic analysis back in kind of 2013, just because we've taken some pond systems offline and turned them into septic systems. We've just built a few other facilities that included them. So the number shifts a little bit as the time goes on, just because our infrastructure changes. We also own and operate 72 public water supply systems. So we're both in the drinking water supply business and in the wastewater treatment business. Then we actually have 4 pond systems, which are surface water discharge facilities, and those are all at rest areas. Then this picture here, this is just kind of highlighting a septic system being constructed here too. So this is a mound system being installed at one of our rest areas. So the original evaluation, it occurred at safety rest area systems, truck stations, and waste scales. And that's primarily just because that's where these facilities are located. And Sarah wanted, and what I really wanted, was a standardized approach to our assessments. And really what the goal was is we wanted a centralized assessment model, so that we were always looking at these facilities through the same lens, and so that every facility, whether it was a small system or a large system, you know, we're assessing that system consistently in the same manner, so we have an apples to apples comparison. And then we kind of wanted that risk analysis approach, so that then we could compare those systems against each other and actually kind of evaluate and rank those systems and prioritize our approach. And really what I was trying to do, I should say, was take a little bit more proactive approach to the SSTS management of our systems versus a reactive approach. And all I really mean by that is I was trying to do a better job at planning system upgrades to our facilities versus, and what is a reactive approach? You know, that's, you know, a pipe breaks or something goes wrong and I get a phone call from one of the districts that we need to do some work. And I was just trying to take some of the reactive approach work and push it into the kind of proactive, or kind of more of a better plan system management on them. And the reactive approach never goes away. Stuff happens, things break. And so I still get the phone call, but I was just trying to move a chunk of that work over into the proactive and actually manage the budget a little bit easier, a little bit better. And the big thing other two was to identify issues before they become emergencies. And by looking at it, by getting that kind of expert evaluation is we could identify issues and then just kind of plan the work and then execute the work. And then always in the back of our mind is make operations and maintenance easier for the end users. And so as we were doing this work is we always wanted to make these systems robust, but easy to operate and easy to maintain. So we did choose a 1 to 5 scale system. And the reason we actually chose a 1 to 5 ranking as we were doing this is actually because in a similar time frame to us doing this work at the statewide enterprise level, the facility condition assessment was starting to occur. And that data is held in Archibus, which is what that image is on kind of on the right of your screen. But that was a enterprise-wide initiative to evaluate all of our facility conditions. And that system that the facilities were using is a 1 to 5, where like 1 is crisis failure and 5 is excellent. Like, and that just means the condition is an excellent condition. And then 2, 3, and 4 would be like poor, average, or fair and good condition. And so we just use that. And the reason we use that is so that we didn't create yet another system that we'd have to learn, and that we were using a system that enterprise-wise was already being used, and so that the assessment could be translated easily into Archibus and back and forth. And so that there was a kind of a 1-to-1 and apples-to-apples comparison with some of the other initiatives that were going on statewide. And here what I've actually had circled on the screen here and is that this is the Kell River rest area that I pulled up here too. And this is the actual condition assessments. And so we have staff that went out and looked, and they actually evaluated the drain field in good condition, so number 4, and the actual septic tanks themselves 3 in fair condition. So that way we can actually take that data and import that data back into the risk assessment. So we can actually use the data that we're going to collect the other means in our risk assessment. So the facility condition assessment that was coming online at a similar time that we were doing this. Subsequently in 2019-ish, a site condition assessment also became a part of what was going on an enterprise level. And those are physical evaluations of the on-site assets, and those are really condition assessments. So is it in good quality, bad quality, excellent quality, or crisis? As we kind of talked about, or as I talked about, we have 900 facilities, roughly 300 sites. That's a lot of facilities to look at. So the natural cadence of the FCA and the SCA is to look at each of our facilities on a 3-year rotating basis, so that 1/3 of the systems per year. So each facility gets looked at on an annual basis. And the FCA and SCA, that's different, but it's related to this work. And I can actually take the data out of Archibus and actually import it into a risk assessment. That way I'm continually feeding data back into the risk assessment model that we created. So the system itself kind of reinforces itself. And this picture here, this is actually Mike Ligday. He's one of my coworkers. This is actually Mike out in the field collecting data on our sites. So you can actually see he's a GPS unit on his back and a computer on his front. So actually, as he's out in the field, he's collecting real-time data, importing it into the databases, and actually collecting the physical location of where we're finding this stuff. So the FCA and the SCA data that's stored in Archibus, that was that program, that was a screenshot that I showed earlier. We're also collecting the physical location. That was the GIS system. That was actually a Trimble Catalyst unit. So we physically know where all of our assets are located. And so that kind of feeds back into like operation and maintainability of this. Do we know where all of our stuff is located? And can we easily get access to that system? And the answer actually through the GIS is yes, that we can. We get out there and we accurately have mapped all of our infrastructure, and now we can find it so that the end users in the districts, if there's a question, if there's a broken pipe, we at our fingertips now, we can get access to this information. Or with a simple phone call, we can get access and share that information. We also have record and design drawings showing the approximate location of where this infrastructure was installed. And then all of this data then coupled with the risk assessment worksheet is what I use as we're kind of planning and programming additional work. So I come at, when I'm planning my work, I use a number of different pieces of information to help kind of plan the work that we're going to do. And then this image here, this is actually General Andrews, which is the sister rest area to Kettle River. But this is just kind of showing where all of the infrastructure is located on site and kind of the brown orangish color infrastructure kind of heading up the highway. That's actually all of our wastewater infrastructure on that site. And so with the districts, whether they wanted to go into the GS or not, is now they can actually see where everything is located on site. So an example of this process at work. So this was at our Adrian septic system. Adrian, this is actually westbound, so this is heading into South Dakota along the I-90 corridor. So just as a part of the routine inspections that actually Mike Ligday was doing, they found a drain field that was non-functional. So he kind of gave me a call to alert me what was going on. Actually, with another simple phone call that I was able to make to the district, we just through some valve modifications in that drain field, we were able to redirect all of the wastewater to a different drain field that was located on site. So we were able to shut off the non-functional drain field. We were able to keep the facility like operational during this entire work and actually construct a whole new drain field on that. And I kind of wanted to just highlight that is because maintainability and operability and actually not shutting down a rest area. We want robust systems. These systems operate 24/7, 365. And so even just modifying the valves and being able to redirect wastewater, that's why we didn't actually have to shut down the rest area to do this work, is there was enough redundancy in our wastewater infrastructure that we were able to just make a few simple modifications with a couple valves that we had actually designed into the system to keep the system functional, keep the public and the environment safe, and allow us to actually do additional work. In this image here, this is actually us just building the two new mounds. We built new mounds at Adrian, and these are the two mounds being installed. This is the sand layer being put on top of the drain field. The other thing that, and Sarah talked about this too, is that O&M manual. That was a critical piece of this. Like, so the work that we did kind of highlighted some of the information gaps that we had in areas that were pretty easy to enhance. And so O&M manuals, we created and wrote O&M manuals for each facility. The O&M manuals covered the organization of the system components, so tanks, lift stations, sewers, drain fields, and other components, the maintenance requirements, as well as some troubleshooting. So if something was going wrong, it gives ideas for how to fix those issues. And really what we were trying to do here is, especially as retirements occur and people that were familiar with the wastewater infrastructure leave and new people come on board, we wanted to make sure that there was kind of continuity of knowledge and that was passed down. And one of the ways that we did that was through these O&M manuals. And Sarah kind of highlighted this a couple of times too. Like, these systems typically are not the systems that are in people's backyards, which is a tank to a drain field. This picture here is actually, this is at the Tetagooch State Park / rest area up on the North Shore. If anybody's ever been there, there's a bridge just before you get to Tetagooch. Our force main to our septic system actually runs underneath the bridge attached to the bottom of the bridge deck. And so this is the force main from the septic system. And the drain field is across the river valley from where the main septic tank and lift station is located. This is a complex system, and there's a lot of different controls going on, and heat tape and heat sec systems in order to keep this pipe from freezing. So our systems get quite complex quite easily. And if the next generation of like MnDOT employees, and in this case DNR employees, don't know how to operate this, that's a big issue. And so these O&M manuals are a way to actually put additional information at the fingertips of the end users, or I shouldn't say the end users, as the operators of this. And so then the pumping, that's always out there and a complex issue for us to kind of like manage. We end up needing to pump our septic tanks. I'm going to say 2 to 3 times a year, with probably 2 times per year being the most frequent pumping that we have. Some facilities are 3, some are 1 time a year. We have a significant solid loads to our tank, and that's mainly toilet paper and human waste. If you think about, especially our rest areas, that's the only usage that's going on there, with some incidental cleaning going on. So a lot of solids go into our tank. Our tanks fill out quickly, and the content in the tanks don't tend to not break down very well. And so we pump those tanks frequently. So we spend a lot of time, energy, and effort trying to figure out how to pump our tanks better, or actually design systems to improve the pumping so we don't need to pump as frequently. And that would be the ultimate goal. One of the things that we did is early on is I actually gave sludge judges, which are just a tool to measure sludge in the tank, to all of our districts to help them optimize their pumping. And kind of what came out of that is that 2 times per year was just about right for most facilities, and usually right before the busy season, and the busy season for rest areas is summer times, and just after the busy season, which is typically fall time. And this image here, this is just a cover page of what one of our O&M manuals looks like for our wastewater systems. The other aspect that's going on out there too is that we have there's been an executive orders out for a number of administrations. Dayton had a couple of executive orders with water reduction, and Governor Walz similarly has a water reduction executive order out there. And really the current executive orders to reduce water consumption at our facilities by 15% by 2027 relative to a 2017 baseline. So that's the goal that we're working at. And what that means is that we're taking the water out of the sewage, which increases the waste strength of our sewage. And so we're just really understanding what the implications of that. The only real lever that we have in order to reduce water consumption at MnDOT, it actually is, especially at rest areas, is the fixtures that we use. So we look a lot at the urinals and the toilets, and we try to reduce the amount of water that those fixture units use. And really what we're doing now is we're really looking at 1/8 gallon per flush urinals and 1.28 gallon per flush toilets. And that is a surprising amount of water that we can reduce just by changing that. Rest areas are high intensity buildings when it comes to water usage, and they use more water than any of our other facilities. Their primary purpose in life is, for people to come and use the restroom and flush the water down the toilet. And so they're just these really high intensity buildings. So at Marion Rest Area, we did a fixture replacement there. This was an older facility, and I'm going to say they just had older fixtures there, and they had some old 5 gallon per flush toilets. And we took those 5 gallon per flush toilets down to 1.28 gallon per flush toilets. And we actually did that replacement in May of 2019. And so the highway was shutting down due to construction, and the building was going to shut down as a result. So while the highway was shut down, we actually came in and at that time, that's when we did all the fixtures. And what we actually ended up doing was saving about 1 million gallons per year with just a fixture upgrade. And so the one thing we didn't do at this facility at the time is we didn't go down to an 1/8 gallon per urinal flush. We just took those down to 1 gallon per flush. But interesting and anecdotal note is the urinals are the #1 thing we can actually do to reduce water. Like the urinals, they're just a high usage, high frequency device. And so the lower we can drive the urinals, the more water we use. And what's funny about this is prior to the fixture replacement is the flows were so high that we actually were struggling to discharge. So it was a pond-based system. We were struggling to discharge all of the effluent from the pond during our discharge period because there was so much water. And in the 5 gallon per flush toilets, when those would flush out of the gravity sewer system, it was like a fire hose. Like there was just so much water shooting out of that system. It was a lot. And so that was a pretty big success story for us. And unfortunately, we don't have a lot of those facilities that had that old of fixtures, but they do exist. And we've been actively working to get rid of them. The other thing is the public outreach campaign. This was a big one. Sarah kind of showed you the signs on the right, which was more educational. The biggest thing, and what I always kind of coin this as, is we're actually trying to modify the behavior of the users a little bit. So we tend to have a captive audience when people are using the rest areas, especially when they're in the stalls. And so the sign on the left there, the not a garbage can, we put those on the back of the stall to try to encourage people to not put anything other than human waste and toilet paper down the toilet. So we don't want cigarettes, we don't want tissues, diapers, pairs of jeans, underwear, especially needles. We're trying to encourage people to get rid of that stuff in a different location, not down the drain. So what happens when it goes down to the drain is we still end up having to manage it. It's just we ended up having our septic tank pumpers end up dealing with it, and they pull all of that out of the septic tank when they're pumping, and they can pull out 5 gallon bucket full of needles just because so many needles get get flushed down the drain. And we have people, I literally will flush jeans down our toilets and t-shirts and underwear. And so there's all sorts of stuff that people flush down the toilet. So this was trying to get us to improve the performance of our systems by actually encouraging the public to use the rest areas as they're meant to be used, and specifically the wastewater system, and to stop putting stuff down the drain. So just kind of to summarize, so the risk assessment really kind of helped us increase our knowledge of all of our systems. And it was a tool that we still use to this day to help us prioritize improvements to our wastewater systems. And really the kind of goal is to move from a reactive to a proactive approach. And we've done a lot with that and continue to do a lot with that. And so it's been really useful. And the other thing that initial assessment helped us do is it identified some of the knowledge gaps that we have and allow us to focus in on areas to improve those, specifically the operation and maintenance. And one of the things I started this off saying was I have almost a laser focus on maintainability, operability, and redundancy and resiliency in our infrastructure. And so everything that we do is always focused on trying to make these systems as robust as possible, but as simple to operate as we can be. And some of that's why the manuals became helpful. Those were knowledge management issues, tank pumping. We continue to look at that because we can reduce pumping. That makes these systems easier to use. And then the data storage, just having data at people's fingertips or easily accessible versus kind of, filed away in an office that nobody can get access to. So improving some of those things to improve the operation and the long-term maintainability of the systems. So a lot came out of this. A lot continues to come out of this. And so it's been really useful for MnDOT. And with that, I had my 15 minutes there. And so just thank you, everybody.
Thank you, Neil, and thank you, Sarah. Neil, really? Jeans down the toilet? That happens? I don't even know how you do that.
Yeah, I always kind of wonder that too. I think you just keep flushing because somehow it was so bad at the blue earth rest areas that we actually had to put in a muffin monster, which is just a grinder system. Because on a monthly basis, there was a pair of jeans that got flushed down those toilets.
Huh. All right, then. Yeah, very, very interesting presentations from both of you. I think at this point we can take questions. So if you have any questions, please do put it into the Q&A, and I will turn it over to Mauricio to facilitate any questions that we can get in.
Right, so I don't see any questions in the Q&A box. So I want to encourage anyone in the audience who has a question to use the raise hand option on Zoom, and then we can unmute you and listen to your questions. So I think both presentations were really great and informing. So just want to encourage anyone not be shy and raise your hand.
I can start with a question. I have a question for Sarah. On the salt washdown, I've come from a stormwater background, and there's we're getting a lot of chlorides being washed through stormwater systems. Did you look at that at all to add to the brine collection that you were trying to do?
We did not, and Neil might have the numbers better than me. Honestly, our biggest issue when we went to put in the pilot facilities was storage. So timing of when stormwater is made, so that I think that would be the biggest challenge. When stormwater is made and when you need brine made are not usually that close to each other. Like that's kind of the perfect thing about the truck washdown water is it's happening at the same seasonality. So they would need a lot of storage potentially. I would also guess that the salt actual concentration is low in comparison. You would know better. I don't do stormwater chloride monitoring, but like we're talking about like off the chart, sometimes chloride numbers coming off of these, which has its own challenges when you think about where sometimes that water is going. But so we didn't. So I don't know if you have any thoughts about that, Neil.
Yeah, right. And I was going to say, I think off of the truck wash water, it's roughly like 3% salt is traditionally what we were kind of finding in our holding tank systems. And the storage was the key one is that when the truck washing was occurring, like that's typically after the storm. So then we store and create and have to make that in preparation for the next storm. And so there is the alignment of the water that we have available and to when our snow and ice operators actually are prepared to make brine. And so, and there's actually there's not as much real estate as you think on our sites to store all of this water.
Thank you.
Can you see the question in the chat? I don't know if you want to read.
Yeah, so the question, just gonna read it. How do you deal with areas of mostly clay soils?
How the rest of Minnesota deals with it. So that's one of the biggest reasons why we use a lot of mound systems in Minnesota and Wisconsin. I would actually say more southern states tend to use more drip irrigation, drip dispersal, but because of our climate, cold climate, we don't really do a lot of drip. So mound systems are designed to pre-treat the water that by the time it gets to the clay, we no longer have contaminants. We're really dealing with water. So we spread the water out over a very large area. So the sand cleans it up in the mound, and then we really put in a really big area. And so they're sized based on the clay content of the soil and how much water it can accept.
Yeah. So I have a question myself. Oh, and there's one, but before that, let's answer one from the audience here.
Yeah, it says like declining water tables. So the water table monitoring we've done to date on the sites we've been monitoring has, again, we're talking about, we're almost probably at 10 years, 9 years of water table monitoring, has not showed lowering water tables. Certainly in years when we have, again, and I think the other thing I need to clarify about water tables is a lot of Minnesota sites have two water tables. One is a perched water table, and one is the ground water table we think about where we pull groundwater from. We are protecting all groundwater. So we are protecting those shallow aquifers, because the shallow aquifers feed lakes, rivers, and streams, or deep aquifers. So we have to date have not seen those water tables decreasing when we have a super dry time period. So going into this fall, certainly water tables were lower, but then you get 10 inches of rain in 2 weeks, and guess what? They come up, because those shallow aquifers tend to hold water when we do get it. And we want to make sure that when the water leaves that shallow aquifer, it's clean.
Perfect. My question is regarding extreme weather events, and what challenges do you see in these septic systems with extreme weather events, and then the connection to climate change? In particular, we have warmer winters and we have more precipitation. So if you could talk about extreme weather. And the other question I had is that when I worked for Metropolitan Council, I remember that one of the work that our wastewater treatment people were doing was related to somehow gathering data on COVID through like the wastewater through the sewage. To me, that's really interesting, because with these rest areas, you could probably get very good epidemiological data. So if you have any thoughts on that, I saw you had like data on, for example, what pharmaceuticals and what illicit drugs were being dumped in the water. So yeah.
Okay, let's talk about climate change first. So warmer and septic systems is better. So when it comes to so we rely upon natural microorganisms to do the treatment for us, and they would all rather be in the Bahamas than Minnesota. So they eat more, they consume more. So warmer is good. Wetter is not. So the wetter is a little harder, because certainly it's very clear that our events are more extreme. But the whole question about, are we, certainly across the United States, we know there are areas that are certainly wetter overall and dry overall. And I'm not quite sure where we lie right now. So certainly in general, wetter soil conditions are not good for septic systems. So if we are designing based on historic water table levels and it gets wetter, the systems we design may be inferior. They may not be meeting that 3 feet of separation I talked about. So that is kind of the risk. And, thankfully we don't have sea level rise, because certainly there are other septic systems across the country that is a very, very large issue. I'm going to do the COVID one, and then you can chime in too, Neil. So we did gather some COVID data during the pandemic, because one of the concerns, if you all remember, is that people from the city were leaving the city and going to outstate Minnesota and spreading it to areas that didn't have the infrastructure. So we did do a little bit, and we actually tried through a MnDOT funding stream to get some more resources to look at it, because it was, very expensive to run a lot of that analysis, and we weren't successful. So we did a little bit of looking, and, I'd have to pull up those slides, but we did think about that rest areas were this location that lots of people went to, and they stayed open and stayed busy. Like, people didn't stop using them, because everyone was driving to their cabin or going wherever, and truckers kept trucking, right? So I wished we had used them a little more than we did. And honestly, I also don't think we well understood as a country how COVID was going to continue. I think people thought there was this early peak and it was going to kind of fade off. And that little peak in the beginning was just the beginning, right? So it would have been a good location to potentially look at it. And we even thought about like, you could monitor the rest areas at Wisconsin and Iowa and look, are they bringing it in or is it leaving, or all of those things. So yeah, it would have been more interesting to gather more data during that time, but and we did find it. It was there. I mean, it was at rest areas, which isn't probably surprising.
Thank you so much. Well, I don't see any more questions, Katie. So I don't know if we want to move on to the next part of the.
Yeah, that sounds good. Again, thank you, Sarah and Neil, for your presentations today. It was really interesting to hear about what we're doing. I work so much in urban areas that I sometimes forget about what's happening that's cool out in the rural areas. So thank you so much for that. And next we will move on to our round robin. So if anybody wants to share anything, you can put something in the chat, you can put it in the Q&A, you can use the raise hand feature if you would like to verbally share. And some questions just to think about that we're looking for are, what current transportation issues related to environment and energy are you or your organization working on or facing? Do you have any organizational, informational, or event updates to share? And what ideas do you have for potential future council meetings, topics, or speakers? And it looks like we have something in the chat already that might be the questions. Oh, go Twins.
I think those are the previous questions that they both answered. So thank you.
And I know Sarah was off to a Twins game, so I think she had to head out. So, and then I don't know, Mauricio and I are both new to our organizations. So I don't know if you have any updates with your work, Mauricio.
Yes.
And then, yeah, go ahead.
Yes, and one of the things that I doing at this new job is actually working even more intentionally on transportation. So we are the Hennepin County has a climate and resiliency department, and right now we have a team of around 7 staff. So a lot of what we're working on is on leveraging a lot of the opportunities that are emerging at the federal level. We have this strategy to reduce vehicle miles travel in the Hennepin County. So we're working across departments to carry out this plan. It's a multi-year plan, and of course our goal is it's in the longer term. Is in the by 2040 have a 20% reduction on our vehicle miles travel per capita. So that's part of the work that we're doing at Hennepin County. We're also applying for grants around electric vehicle infrastructure to be able to, just increase the number of electric chargers in our facilities, and also to promote electric charging outside of our operations, and to do it in an equitable manner. So right now we're exploring a really interesting opportunity to see how the car sharing system in our region is working, in our county is working. So working with our car and other partners to apply for opportunities from Department of Energy to explore what can be done in that realm. So a lot of exciting work at Hennepin County, and it's a great time to be in the organization just because of how much is happening both internally and outside. So
Where do you see the biggest gaps in the EV charging for us, or have you not done that analysis yet?
no, I think there's a lot of work to address the gaps. So the gaps have been identified and they're being addressed. So for example, there's currently project to extend to implement vehicle charge, and that's a MnDOT project actually. The is looking at having charging stations that are accessible within 10 minutes of I-94 and I-35. So that would be a really great, that will add a lot of like reliability to the system. And, you know, a lot of the fear that people have is that they're gonna run out of battery and they are gonna be in the middle of nowhere. But it goes beyond that. It's also like, how do we make it equitable? So that making sure that electric charging is something that is also accessible to people who live in multifamily buildings where they might not have their own like garage. Then we can work with, for example, the utility to see how we can promote charging station for multifamily buildings. We're working with the cities and working with other partners to kind of create a comprehensive plan for electric charging.
Great, that sounds interesting. And I just recently became the owner of an EV, so I am also
Oh,
personally
really?
interested.
Congrats.
Yeah, thank
How's
you.
it going so far?
Great. I love it. I liked it more than I thought I would. So
So quiet, right? It's like very
yeah,
quiet.
yeah. And I don't even
And
have a charger at home, and I've been fine. So
oh, so where you charge?
at work.
At work. Okay, that's
Yeah.
nice. That's so
Yeah.
convenient. And you
Yeah.
save money, right? Because then you have to be, you know, using gas.
Yeah, it's a lot less expensive to use the electric for fuel. Yeah. All right, I don't see anything else in the chat, and I don't see any hands raised unless anybody else sees that. Just scroll through the audience list. And just as the last thing then, to remind everybody to register for the CTS Research Conference on November 2nd. And with that, I want to thank our speakers again and all of our participants. We're always happy to have you. So thank you for being here. Have a great day.